So, good morning to all. Hello, can you hear me?
Yes, sir.
Okay. So, Joshua, good morning. Anna, good morning. And Johan, good morning.
Good morning, sir.
How are you now?
I'm okay.
Okay. Yesterday you saw video.
Yes, sir. Yes.
You understood yesterday
Yeah.
what I
Graphs.
taught it? Yeah.
Fine.
Is it easy?
Yeah.
Okay. Today we'll learn how to make a graph of an equation. If random equation is given it to you, so how will you make the graph of that? And today we're gonna learn that. Okay. So now, everyone turn on the camera. Anna, can you turn on the camera, please?
Yes, sir. 1 minute.
Johan, can you hear me?
Oh, yes, sir.
Yeah, good morning.
Good morning, sir.
How are you?
I'm fine. How about you?
I'm also fine. Little cold is there. Okay. Now, today we'll learn about making graph from an equation. Like if equation is given it to you, oh my God, I forgot. If equation is given it to you, so how will you make graph from it? That's the main. Okay. For example, if equation like x plus 1. Okay. So equation, for example, x plus y is equals to 9. If this equation is given it to you, so how will you make graph of it? So first of all, understand one thing that this is linear equation. Why linear equation? Because the maximum DOP or the maximum power of this equation is 2. That's why degree of point, no, maximum power is 1. That's why the DOP of this equation is also 1. If DOP, degree of polynomial of this equation is 1, that's why it's called as linear equation. Now it's one variable or two variable? It's two variable because x and y are the two variables which are used in this equation. Understood, guys? Yes or no? Now, so the in linear equation, one variable or two variable, the graph will be straight line. Like always, it's gonna be straight line. So if I will make one graph, like rough graph for you, then it's gonna be always straight line, like this. It's gonna be always straight line. Understood, guys? No. Okay. So in linear equation, one variable or two variable, the graph will be straight line. Guys, did you understand? Yes or no? Now the second one is in quadratic equation. In quadratic equation, okay, graph will be parabola. Not ebola, it's parabola, okay? Don't be confused with them. Okay. So parabola we gonna be like this. Either U shape parabola, or either you can make dome shape parabola. And how to make that, we'll learn that thing also. Like, so this is called as parabola. Parabola pathway, like when you follow Olympic Games, Neeraj, who's the athlete, who just throw the uh, throw that thing forward. Javelin throw. So when we throw that, so if the travel gonna be like this, like if we throw from here, so it will go some height, then it will go like this. This pathway is called as parabola. So in the same way, the graph created by the quantity equation is parabola. Okay, understood, guys? Yes or no? Joshua didn't understand. Joshua, tell me what you didn't understand.
I understood, sir.
Okay, quickly write it down. Hello, Ezekiel.
Hi, sir.
Hi. You are late?
Yeah. I was not at home actually. I had gone out in the morning there. Forgot about the tuition.
Uh, it will take time. Done? So, Ezekiel, we learned about the linear equation that it will make a straight line graph and the quadratic equation. Now, you didn't understand the quadratic equation, but it's an equation in which the maximum power of the equation is 2. If you will see that video, so you will get that. So it will be the graph gonna be like looking like this. Yesterday we learned about graph now, just pointing the numbers. So today we're gonna learn that how to make a graph for linear equation. Just write it down, and if you will see that video, then you will get it. Otherwise, just ask me. I will make it clear in the next like incoming.
Okay.
Joshua understood, beta.
Yes, sir.
Today you are also little bit down. No,
No, sir.
yesterday you slept along, na? That's why you're not able to open your eyes. Okay, shall I read this? Okay. Linear equation. Now, linear equation in which variable? One variable. uh, no, two variable linear equation in two variable. We're gonna learn how to make. Now, don't write and just listen to me. Okay, like for example, if the equation is like this, x plus y is equals to 2. And if you want to find that how to make graph, so first of all, you have to make table like that. You have to make table like okay. Any problem? Can you make this table? Okay, not now. Mean you have to make the table like this. Okay. Now, first of all, any variable. I'm telling any variable you can send it to the right hand side. So, for example, I'm sending y to the right hand side. So it's gonna be like this: 2 minus y. Why minus y? Because it's plus y. When it will go the other side, it goes to become minus. It becomes 2 minus y. Any problem in that? Joshua, Johan, Anna, no problem with that. Hmm? Now, now what will happen? See, the y is at right hand side and the x is at left hand side. So, because y is at right hand side, so you have to choose any value of y. You can take minus infinity, 0 to any infinity number. You can take any number. I'm saying. Which for which variable? For y variable. Y variable because it is at the right hand side. Understood, guys? No. Now, what is right hand side for Joshua? The equals to right is right hand side. The equals to left is left hand. So, because the y is at right hand side, so you can take any number 0, 1, 2, 3, 4, 5, 6, any number you can take. So, okay, to find the value of x. Okay, how will you do this? So, for example, I'm taking first y value as 0. So I have to put, like I will solve this, x is equals to 2 minus 0. Why 0? Because instead of y, I am writing 0. I took value as 0. So it's going to be like this, x is equals to 2 minus 0, x is equals to 2. So I got x is equals to 2. So when I take y value as 0, I will put x equals to 2. Understood? No. Okay. Now Joshua will tell me. Joshua, tell me another value, please. Any other value of y?
1.
So if you will take 1, then what will be the value of x?
X is equal to 1.
1. Very good. So when you take y value as 1, then x is equal to 1. Understood? No. Hmm? Now, Anna, A for Anna. Anna, please tell me which value you will take. Yeah.
I put
Sorry?
I could put 3 or something like that.
Yeah, take any number, I'm saying. You can
3.
take 2, 3. You can take your birth date, any number. 2 minus 3. So what will be the value of x then?
It's minus 1.
Very good. Still here, any problem, guys? Yes or no? Huh? No problem. Now I'll erase this. I mean, I didn't have space to make graph with this, so that's why I'm erasing this. Okay. So till here, you can write it down. Till here, you can write it down. And if you have any problem, then ask me, please. Done? Everyone? Okay. Now here I got three coordinates. Like if I will make arrow like this, so x comma y, I got three coordinates. The first coordinate is uh, 2 comma 0. Yes, because the value of x is 2 and the value of y in this condition is 0. The second one is 1 comma 1 and the third one is, can you tell me? Minus 1 comma 3. Understood guys? Yes or no? Now I will make the graph. Okay. Is this graph correct? I'm asking this question. Is this graph correct? Or am I missing something? Tell me. Is this graph correct? Yes or no?
So shouldn't you label if it's y-axis or x-axis?
Yeah, good, good. So I have to write y-axis and x-axis also. Otherwise, you will lose your mark. Okay? Like that. Okay. Now I have to mark this point. So first mark is 2 comma 0. So I'll annotate to Joshua, and Joshua will mark these points because I want him to do this. Yesterday he was like missed the important class. Joshua, you can annotate now.
The 2 0. The 2.
Yeah, 2 comma 0. Where will you locate that point?
So the 2 of the x-axis
Yes.
and the uh, and the 0 of the y-axis here.
Yes. Where will you place? You can annotate. You can use pencil. Like you have option that pen. Can you see your computer screen?
Yeah.
Yeah. So you can mark where you are staying.
Mm.
And Ezekiel will mark the B point. And Anna, A for Anna. Anna will mark the C point. Quickly. Joshua A.
Is it here?
Okay. Okay. Ezekiel, second yours. Okay. Joshua, yours is a bit wrong. Why I'm saying that? See, you can see it's written as 2 comma 0. Okay, 2 comma 0. Now, if this is 2 comma 0, so on x-axis we need 2. So in on x-axis where is 2? This is 2.
Yeah.
And 0 comma 0, like y-axis we don't need anything. So we'll put here only. gonna be like this.
Okay.
Okay, because on y-axis we don't need. Your point is like this. Here y-axis is like 0.5 now. It's gonna be wrong now. So that's why.
Oh, okay.
Okay. Now I got 3 points. What are the 3 points? These are the 3 points which are different in color. Okay. So now I will make a straight line going through it. Gonna be like this. Yes or no? This is a straight line. No? This straight line denotes the graph, which is what's the graph? X plus y equals to. This is my straight line graph. Understood, guys? है ना? समझ गए? Everyone? Ezekiel? हाँ? है ना? Johan? Johan, did you understand, beta?
Yes, sir.
Perfect. Write it down. मम्मी को देना. एक को देना. Done? Shall I do this? Can you hear me?
Yes.
Okay. Today I will give you little homework. I know that you feel little burden. I will give only little. That's the perfect. Okay. Now we'll make one more graph. So the graph is x minus y is equals to 7. So now Hannah will tell me the step by step to get the value. So minimum 4 values you need. Yes, Hannah, tell me quickly, step by step.
Get is x equals to 7 plus y.
Yeah, you will send plus minus y to the other side, it becomes plus y. Very good, then.
And you have to figure out guess values for y.
Yeah, so you tell me.
1, 5,
So if you're taking y as 1, so it means this x will become 12
5,
x is equals to 7 plus 5.
yeah,
You want to take 5? X is equals to 12. And next,
minus 3,
minus 3. Okay, guys, one thing I want to say, see, you can see that when I'm taking y as 5, then it becomes 12. So it's gonna be long, means you have to make long bars to get 12. So you can adjust your numbers like that, that it should come near to 0, so that the short graph can be formed and it becomes easy for you. Otherwise, you have to make 1, 2, 3, 4, 5, 6, 7, 8, 10. Like if I will take 13, y value as 13. If I will take y value as 13, then what will happen, you know? So I will take y value as 13, then x equals to 7 plus 13, x equals to 20. So it means that 20 lines, when you're making graphs, so 1, 2, 3, 4, 5, 6, like this, 20 you have to make. And you will be short of paper also. So what you have to do, you have to take that number, like as I told you, you can take minus number also, plus number also. So you have to be near to the 0, like this 0, 1, 2, 3, 4. So if the number is nearly about 10, under the 10, like x and y, minus 10 plus 10, no matter. So uh, that's gonna be easy for you. Understood, guys? No? So now you have to play with the numbers also. So yeah, can I take 3 so that it becomes 12? I mean, it will become 10. Yeah, so it will become 10. Next part.
minus 5,
No, minus 3 you said, no? So when you will take minus 3, then what will it become?
4,
Yes, very good. And then
minus 5,
minus 10 off.
minus 5,
And yeah. So now, one by one, each of you will mark the spot. Okay. Okay, now do that. So now Joshua will do this one. Joshua will mark this one. Anna will mark this one. Ezekiel will mark this one. And Johan will mark this one. Johan, are you there? Johan, can you hear me? Hello, Johan. Can you hear me? Okay, so then Hannah will mark this one. I'll repeat it again. This one is Joshua. Joshua, mark this one. H, comma 1. Anna, Ezekiel, Hannah. Joshua, mark it quickly. Yeah, very good. So now, the graph. Got it, guys? And you have to write the equation also, which equation you are taking. Like the equation is x minus y is equal to s. Quickly do it, quickly. Done? Everyone done? Yes or no? Okay, Anna, Joshua done. Okay, shall I raise this? Now I will give you one equation. You have to make the graph. and I will check you on the in the camera. Okay. So make the graph of this.
Sir,
Yes.
uh, so I have a doubt. What do we have to do in the 2y? Should you also add that?
2 into y. Yes, it will go like this, no? Like x is equals to 7 plus 2y. Now, whatever number you will take as a y, then it will multiplied by 2 also, no? Like 2 into y it is written, no? So it's simple as that. No need to confuse me. Understood? No.
Yeah. So you have to add it.
No. Like it's gonna be like if you will take y value as 0, or you take y value as 1. So x is equals to 7 plus 2 into 1. It's into, no? Not addition. So x is equals to 7 plus 2 into 1 is 2. So x is equals to 9. It's gonna be like that.
Oh, that's it.
Your homework is check your progress 5.6. Anna wants more. See, she's saying yes. Because Anna wants more, so I will give little bit more than.
Sir, come on, sir, no.
Good. Okay, done. Okay, done, guys. Done. Yeah, show me, Hannah. I can see. Okay, perfect. Anna, done. Anna, show me.
It's all messy, so
Sorry.
I had to scribble some of the things out, so it's a bit messy.
It's okay. I love Ronaldo.
Well, that's good.
Perfect. Good. Joshua, done.
Going to finish it.
Ezekiel, done. No. Got confused?
Yeah, I'll take maybe 1 more minute.
Okay, so you do one thing. You write this homework. You have the book, no? Chapter number
Yes.
5. So you have to do this homework. I'll join you in a 10. You will continue with our class, no?
Yeah, yeah.
Okay. So I'll join you in the WhatsApp group so you can submit your homework there.
Okay.
Okay, na? So I hope you enjoyed the class. Anna, we'll meet tomorrow. Bye. Have a nice day. And guys, you have 3 minutes break. Then come back with the science.
So what is the homework again?
It's written on the board. Homework. Check your progress. CYP is basically check your progress.
Okay.
5.6 full exercise. So you can go on fifth chapter,
Yeah.
and when you will find 5.6, check your progress. It's written. Check your progress.
Okay.
5.6.
Okay.
So question number one and question number two, you have to do it. Full. Okay, you can have 3 minutes break. Go drink water, anything you want to go, and then come back.
അവിടെ വെക്കി പറ്റേല
Okay, guys, come back. Yeah. So Hannah has one question. Hannah, what the questions are in the math format? Do we have to draw different planes for each question, or like question number one, you can do in one graph, but in question number two, each equation you have to make different graph. Okay. In question number one, you have to mark the coordinates. So for marking coordinates, only one graph is okay. You can mark the coordinates like yesterday we did. And for question number two, each equation is given and you have to make the graph for that. And so it means that you have to make every part graph. Like every part has a each graph. Okay. Now, yesterday we learned about impulse. So Joshua, are you there? Can you hear me, Joshua? No? Yesterday we learned about impulse in the like change in momentum, like final momentum minus initial momentum. Now today we learn about second law of motion, second law of motion, which says that the rate in change in momentum is like the perfect line. Yeah. The rate in change in momentum is directly proportional to is directly proportional to the force exerted on. The rate of change in momentum is directly proportional to the force exerted on it. Okay, what does this mean? Yesterday we learned about don't write. Yesterday we learned about change in momentum. What is change in momentum? Final momentum minus initial momentum. Joshua, I hope you saw that video yesterday also. Impulse we learned yesterday. Okay, the final momentum minus initial momentum is basically the change in momentum. Now there is a rate. What does this rate mean? So in physics, whenever rate will come, like rate of change of this, rate of change of this, whenever rate will come, you have to divide that thing by time. So I'll write this thing. Like generally I'm saying, whenever rate will come, you have to divide the thing by time. You have to divide that thing by time, like divided by t. Simple as that. Divided by t. You have to do that. Understood? No. Okay. So now the rate of change in momentum. So first of all, you have to find the change in momentum. Now, change in momentum is basically impulse. Yesterday we learned that change in momentum is basically the final momentum minus initial momentum, and it is given the rate in the change in momentum. So the rate means you have to divide it by time. Understood, guys? Now, this is the theoretical meaning. Now, what is the practical meaning? So yesterday I told you, see, this is the bottle in front of me. Can you see that bottle? I know it's blurred. I'll remove the blurredness. Okay, now can you see that bottle? Is this your bottle? Is this bottle? Now, if I will, this is my hand. Now it has some velocity and it's gonna hit this bottle. Okay, it's gonna hit this bottle. Now understand it like this. When I will hit this bottle in this way. So I am changing my momentum. Like it is coming in fast and it becoming slow. So I'm changing my momentum, like fast to slow, in a great time, like 3 seconds, 4 seconds, 7 seconds. Understood? Yes or no? So I'm changing my momentum in great time. Okay. And the second example is I'm changing the momentum very slow. So I'm just hitting it. Okay. So I'm slowing my hand, but in which case the force is more. In which case the bottle will flip for a farther distance. In the second option only, because I'm changing that momentum, the momentum of my hand in very less time. Understood, guys? Okay. So I'm changing that momentum very less time. That is why the rate of change of momentum in this case is very less. So the force exerted on the bottle will be much higher. Understood, guys? So what this second law of motion wants to say that the rate of change in momentum, which is Pf minus Pi, means final momentum minus initial momentum, is directly proportional to the force acting on it. Oh my God. Understood? So if less time, I'll change my momentum, there'll be much greater force. Understood, guys? No. If less time will be there, then there will be much greater force. Okay. So and now we have to find the value of that. So please don't write. First, listen to me. So like force is equals to mv. Like the final momentum is mv minus initial momentum is mu and by t. Yes or no? Did you know now how I wrote this? The final momentum, the final velocity, mass into final velocity, which is mv, mass into initial velocity, which is mu, by t is directly proportional to the force acting on it. Now, can I take out m as a common? If I will take out m as a common, so it will become v minus u upon t. Yes? Yes or no? So f is directly proportional to m. Now I will ask question from Hannah. What is v minus u upon t? V is final velocity minus initial velocity upon time. What is that? V, yes, it's acceleration. So F is equals to m into a, and F is equals to kma. K means K means constant, which value is always 1. M is mass, which is like kg mass, whatever kg, and A is acceleration. So for acceleration, for Ezekiel, because he is new, acceleration is basically the you can understand it like this: change in speed. Acceleration is change in speed. Like for example, this is bottle. It has rest. Okay. Now when I will move it, oh my God, like I'm doing magic. Okay. So when I'm doing magic, it's moving. Yes. And when I will call it, it is coming. Okay. So the acceleration is basically the change in speed. Okay. Change in speed, like it is at rest. Now if I will tell move. Okay, it's moving. Okay, so this change in speed is basically called as acceleration. Like how much time it it get to get the speed. Understand like this? Okay. Write it down. Joshua understood? Joshua.
Yeah, I understood.
Good.
But
Yes.
there's one thing. What is the?
Sorry.
I didn't understand the mv minus mu by t.
See, yesterday only we learned that final momentum. Tf is called as final momentum. Momentum is equals to mass into velocity. Now, final momentum means mass into final velocity. Initial momentum is mass into initial velocity, which is u. Okay, now I take out m as a common, then v minus v upon t is acceleration we learned. So that's
Got it.
okay. Good. Ezekiel, any doubt, beta? No? Okay. Write it down. Quickly write it down. Quickly.
So what is MV minus MV?
This
No, to the left.
mv minus mu upon t.
I mean, I forgot what MV and
M mv is final momentum. Mu is initial momentum. V is final velocity. U is initial velocity. Ezekiel done with the writing? Yeah. Done?
Yes.
Okay. Now I request okay, first we'll do some questions on it. Amazing. Okay, can you read the question, Ezekiel?
Calculate the force exerted by the body having mass 10 kg and moving with an acceleration of 5 meter per second square.
Yeah. So we have to calculate the force. So how will we do this type of question? So force, we just now we got the formula. Force is equals to mass into acceleration. Okay. Now force, the mass. How much mass is I got? The mass is 5 kg and acceleration is 5 meter per second square. So 5 into 5, because mass is 5 and acceleration is 5 meter per second square. So the force will be 25 Newton. Now Newton is basically the unit of force, which is equals to kg meter per second square. So either Newton you can write or either kg meter per second square you can write. Okay. And for Newton, which is the unit of force. Understood? Yes or no? Write it down.
So isn't the mass 10 kg?
What do you think?
Isn't the mass 10 kg?
No, it's 5 kg. You can see that, no?
We can see it now.
Yeah, good. Okay. So now take out page number 233. Page number 233. Module number 3. Force. It's okay if you don't have Ezekiel. Just listen now. Tomorrow, please sit with you. Okay. So I'll ask Mr. Joshua, can you do the honors to read the second law of momentum, like Newton's second law, on page number 233? Yes.
According to Newton's first law of motion, the application of an unbalanced force brings a change in the velocity of an object. Thus, the force can produce a change of momentum. Newton's second law of motion establishes a relationship between force and change in momentum. Second law of motion states that the rate of
Now,
change
this is the important line. You have to underline it, okay?
of momentum of a body is directly proportional to the force acting on it and takes place in the same direction as the force. Newton's second law of motion also gives a relation between force and acceleration. Let us derive this relationship. Suppose the velocity of an object of mass m changes from u to v in time, t by the application of a constant force F. The magnitude of initial and final momentum of the object will be p1 equals mu and p2 equals mv respectively. The change in momentum in time t equals to p2 minus p1. The rate of momentum equals p2 minus p1 by t. According to the second law of motion, the magnitude of the force F is F infinity p2 minus p1 by t.
No, it's not infinity. It's directly proportional. It's not infinity. It's directly proportional. Yeah. Okay.
F equals to k into p2 minus p1 by t, where k is constant of proportionately. Substituting the value of p1 equals mu and p2 equals mv, we get F equals k into mv minus mu by t equals kilometer into v minus u.
It's not kilometer. It's k only. K into m. M is mass. K is constant. Just now we learned k is constant. The value is 1. And m is mass. So it's not kilometer.
So it's constant.
Sure. Yeah, constant in mass.
Constant mass into v minus u by t.
So this is basically derivation. So what derivation which we did, that derivation if you will write with the lines. I didn't write add the lines. So you can see this derivation, they can ask you that derive the force according to the second law of motion. Okay, so they can ask you in 3 mark question, so you have to write it. Okay. Then this is derivation, and you just read this part. And now come back to the application of the second law of motion. So Joshua on page number 235.
From equation 10.4, F equals ma.
No.
Here,
Some examples of second law of motion. Read them.
in our everyday life, we see many.
Please listen, guys. This is very important. Like they can tell you where will you apply the second law of equations. So theoretically, they can ask you. So you have to write it down these points. Here, please. Joshua, you can read.
In our everyday life,
Please do the honors.
In our everyday life, we see many applications of second law of motion. In many situations, we try to decrease or increase the rate of change of momentum by changing the time in which change of momentum takes place. Let us consider some examples. While catching a fast-moving cricket ball, why does a fielder move his hands backward? By doing
so, you can understand it like this: when ball is coming, if ball is coming, okay, you know na how to catch a ball, guys, you know na, huh? Who knows cricket? Ezekiel knows cricket.
I know some, but in Kerala, cricket is not considered a very good sport.
It's football, na?
Yeah.
Okay, I know that. Okay, so even the goalkeeper when catches the ball, okay, goalkeeper rarely catches the ball. By the way, like he wants us to defend it, just do the punching with the ball. But in cricket, basically, if you will punch it, it will be not out. Okay. So when ball is coming, if you will put your hand like this, okay, just like this, then the ball will, like, if you will catch it, either you will have a great damage, as well as either the ball, you can't catch the ball at it. So for that ball, if ball is coming, so you have to put your hand in the backward direction. So there is change in momentum, the ball which carries the momentum. When you will catch it, it should be like the change in momentum with the thigh. So that the force which is on your hands will be less. Because if time is greater, if you are changing the momentum in great time, then there will be less force will be there on your, so that your hand will be uh, like it will be safe hand. Otherwise, you will have a great damage in your hands. Okay. So this is what you can. I hope you can just read this part and example 10.1 and 10.2. Do as your homework. Don't see the answer. Just do example 10.1 and example 10.2 as your homework. Read this part and then we'll come tomorrow with the same intensity, with the same power. Okay. So I hope you enjoyed the class. Bye. Have a nice day. Signing off. Tada. Bye bye. Sayonara. Bye
Bye.
bye.